Okay, I have here my 4 performances of the happy piece, and all of my annotations are done, and they're in a pretty good place. I think they sound okay. What I want to do now is I want to export some data, because the data inside Sonic Visualizer isn't so... Sonic Visualizer is great for looking at audio data, but it's not really great for analyzing it. So we want to get some data outside of Sonic Visualizer. So to do that, specifically we want to get out these timing annotations. So we'll select the the layer that we want to export, and it's the time instance layer. So in this case, in the top pane, it's the third layer here. So to export this data, we're going to go to the File menu and Export Annotation Layer. So let's click on that, and then we're going to select a name for it. So let's go to the correct folder that I want to use in Exercise 1. It's a Happy Time Annotations folder, and I actually have some names for these files predetermined so I wouldn't get confused. So name this one Happy Happy. It's the happy piece played with a happy emotion. And we'll save that. And now we'll select the next one. So let's find the layer one. I think it's this one. Yeah, time instance. And we have to select the pane again. Like this. Now it's selected, so you select it on the left side here. And we'll export that annotation layer. That one is the happy piece performed in a deadpan manner. And notice that when I save them, I add numbers to the beginning of the file name, which is very important. So you want the 4 files named 1, 2, 3, 4. So let's save that. We'll find it in this one. Just double checking that it's the right one. And yes, select that pane, export annotation layer. What was this one called? This one was sad. And find the 4th one, time instance. This, just to make sure I don't misspell anything. Okay, great. Now let's move away from Sonic Visualizer for a bit. I'll show you how this data is saved. It's saved inside a CSV file, which if you open it up by default, it'll open in Excel or Numbers or whichever default spreadsheet program you have on your computer. And you can see the data that it's taken now. These are the timings of each of the annotations that we added, and these numbers correspond to the numbers here: 1.1, 1.2, 2.1, 2.2. So we're not; those aren't really relevant at the moment, as long as you have the first column here. Those are the important ones. So now that we have this data, we can try plotting it. So in our department, in our studies that deal with systematic musicology, we often use a software called MATLAB. So let's go into MATLAB and have a look at this. MATLAB is a very, very scary looking program, but it's not so scary once you get the hang of it. It's basically a program that allows you to manipulate variables and data and do lots of nice plots. So it's one of these things where you could use variable to hold, let's see, like the value 1. So now I've typed x equals 1, and if I type x again, I see that it's holding the value 1. Same way, x can hold a series of numbers called a matrix. like this, 1, 2, 3, 4, 5, 6, and now in the workspace I see that X contains a matrix of values 1 to 6. So that's a really quick introduction to MATLAB, but don't worry too much about MATLAB if you're not comfortable using it. If you are comfortable using it, that's great. That's awesome. But for our purposes, we're really just interested in this MATLAB script that I wrote called Plotting Timing Annotations, which you can find in Moodle. So we just double click on this and it'll open in MATLAB. And here in this script there are some commands and there are also some comments. So the comments are all commented out, as we say, using these percentage points. So the comments are green. But down here we have text that isn't green, and these are the actual commands of the script. So what I want to do, I have these for CSV files. I want to import them into the MATLAB workspace so I can do some nice plots. To do that, I've written this script that basically just it finds all the CSV files within a folder or here a directory, and for the amount of CSV files that we have in the folder, it'll import the data, and then it'll store the data into a matrix. So here, if we look at the CSV file, we see like the data is all separate. We want to kind of combine all that data together so that it's all in one single unit, in one single matrix. Before we do that, we have to make sure that we're in the right directory. So to find the directory that you want to be in MATLAB, you can go up here, the directory field, and we'll just find, and we can just go, let's say like you stored things on the desktop, you can just click on desktop there and the current folder will move to the desktop. So, and from there I know that my annotations are stored in Happy Time Annotations. So, and here we are. Now we're in the right folder because this is where my CSV files are. So, to run the script in MATLAB, the script here is divided into 3 sections. So, this is described here if you want to read it a bit more closely, but I'll just tell you that this script is separated into 3 sections, into 3 steps. And to select each section, you just click on the white space here within the section, and that'll select this section. So here I've selected step 1, here I've selected step 2, and here I've selected step 3. So I want to run each section one at a time. There's nothing to run here in the first part because these are all comments. We can run section 1 by going up here and clicking on the Run Section button. So let's see that, and yes, success. Now I have this variable called timing data, and if I go here to my workspace, I see that the matrix contains the annotations for the 4 performances. So each column represents a performance, and the rows represent the timing annotation of that bar. Great. So let's clear this command window by typing in CLC. You don't have to worry too much about that. And let's go back to the script that I have. So now I've loaded in the data, and I want to plot the timing data. So I can click into this next section, step 2, and I'll go up here and run the section once more, and I have a nice plot. What did this plot say? So the plot is just, if I go back here, this plot is just representing the data. So you can see how this data is organized. It's the onset of each bar, and the numbers rise, the numbers increase as you proceed into the performance. And this is seen in the figure. So that's why these lines are going up, because each onset is taking place further and further into the piece. So here we have the bars and the second at which it takes place. So this is a nice representation, but we could have something even more meaningful. So we could look at how each piece differs bar by bar. So to do that, we want to difference the data. So we want to know the timing between each of these cells. Okay, so to do this, we would use a function in MATLAB called diff. We can type it here, diff, and we'll actually, if we add this argument, we can add our matrix as an argument to diff, like this, and put it in these brackets, and press enter. And now in this section here, we have the individual duration of each bar. So these would be in seconds. So in the first, in this column here, we see that each bar is lasting about 0.7 seconds, and then it speeds up a little bit. The bars go on a little faster and slows down. So we can see the difference between each bar, and as you might imagine, if you've heard each performance by now, there's lots of variation in these values from piece to piece. So already we can see this piece, which is the SAD performance, is 300 milliseconds more, it's slower, or longer than the other performances. So I have a hunch that the SAD performance is going to be very different in terms of timing than the other three performances. Which brings me to the third part of a script here in step 3. So here I have the function diff with the timing data as a variable, equating to this new variable called timing data diff. In MATLAB, you can name variables whatever you want. You can name them, Boola or Dallas Poola or something good like that. It doesn't matter what you name the variables. Any name is valid. But here I've decided to keep it quite logical, so it's timing data.diff. So let's run this third step here, and we'll run the section. And now I have another plot. The plot looks very different from the other one because now the lines aren't rising, but you're actually seeing the variation between each bar. And here I put in the legend. The legend indicates which line is which. So this blue line is down here, and the deadpan, that's red. So deadpan seems to be a little bit slower because the values are bigger bar per bar. And SAD is very different. So SAD was played much more slowly, and you could see the variation in the SAD piece. And then we have angry, which is kind of down here. So angry seems to have been played the fastest. No, sorry, happy seems to have been played the fastest, and then angry a little bit slower, and then deadpan a little bit slower, and then SAD very slower. So if you were to run a statistic on this, like an ANOVA or something, the result would probably be that this SAD performance is played significantly differently than the other performances. So to save this plot, we're going to go to File. Within this figure window, we go to File, and we save as, and we don't want to save it as a figure. We want to save it as something that we can use, that we could, drag into a Word document and into our report on this analysis. And we'll use ping, which is a PNG, which I like to use, and we'll name it happy diff, something like this. And now it's saved as a figure. And if you're interested, there are all sorts of things that you can do to make the plot a little bit prettier. You can make these values bigger. You can make the legend more readable. You can even make the lines thicker so that they're they're more, so it pops out a little bit more. Okay, so that's how you do the exercise. So have fun with it, and let me know if you have any questions, either by email or even in the comments below. Okay, bye-bye.